For the environment, we are not really interested with anything that has to do with our main hero character. So we can go ahead and we can just drop down a prune node and let's grab our hero geometry. We can just drag our hero object over here and let's go ahead and deactivate. All right, so for our enemies, we will want to retain their shadows. So from here, we will do a geometry render settings and let's just do a slash and select our enemies. We want the entire group and we'll go below here and we need to set the render visibility here. So let's set or create and we will just make this invisible to primary rays, which is going to give us this expression here. So hopefully now if we render this, we have the shadows from our characters, more specifically our enemies, but we don't have anything else. So this is what we need. And from here, we can just go ahead and drop down a karma render settings node. And let's set up our AOVs and our render settings. First of all, we'll point this to our camera. Obviously, you can choose what kind of file path you want here for the output. Let's also make sure that this is 1080p. For the engine, we want to use XPU parameters. And for this layer specifically, 128 path trace samples should be fine. If you want to increase the quality, you can go ahead and increase this value if you feel that if you feel the need to. And let's also rename the render settings here. We'll start with the environment, so this will be JC environment 01. For other settings here, for the limits, this is looking fine. We don't have any volume or SSS, so we can keep all of the default settings. But in the camera effects, we don't want to render this with any depth of field or motion blur. So let's start both of these off. Technically, we should render with motion blur, but since we are trying to balance so many layers, it's going to be kind of a pain to deal with the motion blur for all of the layers when we combine them together. So in this case, I decided to render without motion blur, but probably for the best results, you would need motion blur, but especially at around this part over here where we have our camera spinning, this introduces a lot of motion blur, which I really don't want. So this is one of the reasons why I decided not to render this with the motion blur. Now, there's ways in which we can avoid camera motion blur but still have the motion blur on our characters. But to keep things simple, I just decided to ignore the motion blur and just add it directly in Nuke after we add all of the layers together, just to make our jobs a little bit easier at the cost of a little bit of quality. So these are all of the settings that we need mostly. So we can go to our image outputs and let's go ahead and start adding our AOVs. So we will need our diffuse, our combined diffuse, split per LPE tag. We need our combined glossy reflection. Let's split this as well. In our lights and emission, we have the emission now from our interior material for the fractured pieces. So we can also include here, let's include direct emission and indirect emission as well. And moving forward, we don't have volumes or SSS. We don't really need this albedo, but we can add our ambient occlusion, always nice to have. And then we'll add all of the standard utility layers that we always have. So we have our world space, our depth camera space. We can also include the textures here, our smooth, normal, facing ratio as well. And that's pretty much all that we need in this tab. And for our extra render vars, we can add, let's hit plus. And first of all, let's start with our crypto matte. So we can use the material name for this. And if we do a test render, let's see how our AOVs are looking so far. And we also don't want to render this without any sky or HDRI. So let's go to our physical sky and disable render light geometry. And our dome light is only visible here because we have this in our settings in the viewport. So if we go to the background here, we can uncheck this display environment lights as background and we can set the color scheme to dark. So we can see we don't have any sky. We can double check to make sure that we don't have any alpha on our background here. So in the color correction tab, we can show our alpha layer so we can see that everything works. All right, so if we inspect our AOV, AOVs. We have our AO, we have our combined diffuse. So let's see if our light splits are working. We have the sky and the sun, and also for our reflections as well. So everything seems to be good. Crypto material works. Our depth, direct emission, this will be for, or actually, since we're not rendering the enemies here, we don't need any direct emission, so this was a mistake on my part. Let's go to the lights and emission tab here, and we'll disable these two AOVs. So let's go back. We have our normal, our position, our UV, and we pretty much have everything we need as far as this environment layer is concerned. So from here, really, we can go ahead and let's grab all of these and place them down below. We can do a ROP. Let's do a ROP USD, or rather USD render ROP. And we want to render the entire frame range. And for the delegate here, let's use XPU, and we can go ahead and render to disk. And if you also want to preview what you're exporting, you can turn on the monitor tab. But I usually like to leave this off, as sometimes I find that it actually slows things down a little bit, especially when using denoising, which we will use on the other render layers later. So once this is set up, let's take a look in how we can set up our enemies. And we can use most of the same settings that we have already here for our environment. So let's go ahead and duplicate all of these nodes to the side. And we won't need our hero either, so we can run our pro node. But here we can also get rid of the mountains in the back. So let's hit space here and do a slash. And from the environment, let's also select this MNT group, which will be our mountains. Now, this really won't affect our render times that much, but it's just nice to optimize the layers if we can. So for our render geometry settings, this essentially gets rid of our enemies. So this is not what we want. We can, let's get rid of this node and let's do a new one. So let's do render geometry settings. We'll start with a fresh node, and we will want to ignore our ground for this layer. So we can go all the way here to the top, and let's stop the render and let's do slash. And from the environment, we want to select our ground. And here we'll set the matte. Let's go to our holdout mode and let's set this to matte. So if we go to our Karma render settings, let's rename this one to JC enemies 01. Let's keep all of these AOVs that we have already set up, and for the enemies, here is where we actually need our direct emission and indirect emission. So if we do a test render, let's see what we have, and everything seems to be looking good. We can preview our AOVs and just double check that everything is working, but I can say that we have everything we need. We have our crypto material, our depth, our direct emission. So our direct emission should be visible at our later parts of the animation where we have our fractures on the ground. So we see them here, and we have our normals, our world position, our UVs, so everything that we need. Let's go back to our beauty. And a few extra AOVs that we can use here will be a smooth depth pass. So if we hit plus here, let's select our depth. So this is the one that we currently have from over here from our utility tab. And this is using this pixel filter here that gets rid of the smooth edges. So let's create one with smooth edges like we usually do. Let's rename this one to depth smooth, and the pixel filter here, let's use our default one, which is the first option in our list. And one more layer that we can use here is going to be an AOV, so we can separate the interior faces of our geometry. So we can just create a primvar on our interior faces, set to a value of 1, and we can use that in our AOV setup here in a very similar manner in which we set up our volumes in the daemon project. So all we have to do is use a wrangle. So we can probably use this after our material library over here. If we drop down an attribute wrangle, we can run this over our interior pieces. So let's go to our enemies and let's select here the inside object. We can rename this one also to add primvar. Let's just keep this at primvar, and let's color this. Let's do a pale yellow. So we'll want to add a primvar, and then we'll have to set the value. So here we can do USD underscore add primvar, and in between parentheses we'll reference our stage with 0, and then we'll do s at prim path. We'll give this a name here, so we can do interior, and let's say that this will be, we can use integer, but probably it's best if we set this as a float value. All right, and then we can just set this. So let's do USD set prim var. We'll do 0 as at prim path, and we want to set the prim var interior, and we set this to a value of 1. And we probably should have saved this as a recipe, so let's right click and save selected item as tool, and we can name this one vox add prim var or something like this. We can save this, and now we should probably be able to just add this whenever we want and just change the primitive path over here. So if we have now this prim var on our interior faces, again, you can reference the lessons from the daemon project if you want a refresher on how all of this works. But now we can go to our Karma render settings. We can add a new custom prim var, and this will be, let's name this one interior. Our source name, let's set this to prim var, so our source name will also be interior, and our data type here is going to be float, and we can save this as a float or a color 3f, but we can just keep this as a float. So now if we do a render, we have our geometry here. So if we go to our interior AOV, we have this selection with just our interior faces. So to alter the texture for this interior faces later in Nuke, we'll need this mask object, or rather AOV. So now we have everything we need for this enemy layer as well. And let's go ahead and also take care of our hero, and let's grab all of these nodes and let's duplicate them over. So for our hero, we'll obviously have to get rid of this hero selection here in our primitive pattern, but we can go ahead and remove the mountains as well. And for our render geometry settings, we'll start off again with a new one, and let's look at another frame where we actually have our hero as well. And let's maybe just preview this from a dome light display. So we get rid of our mountain with this prune node. Let's do a render geometry settings, and we'll want to ignore our enemies and our ground. So in here, let's select the primitives. We'll do slash, we'll pick up our environment and our ground, and here we'll do space, and let's also select our enemies as well. Now if we do here, if we select this, let's set or create our holdout mode. We'll set this to matte for now, and if we go to our Karma render settings, we can rename this one to JC Hero 01. We don't have this interior set up here, so we can get rid of this AOV. We can keep our depth smooth and our crypto material, and also most of these AOVs we will need as well. But here, because we want to add the shadow from this hero, we will want to have this shadow as an AOV that we can control. So in order to do this, we have to go to our render geometry settings, and we have to set this holdout mode here. We will set to background instead. So now in our render settings, we can add a new AOV, and now from this list there is a shadow preset which we can select, which is this third layer over here. So when we select our shadow preset and we do a let's do a test render, we can go to the shadow here, and we can see that we just have the shadows that are visible on the character, but we want to have the shadows only that our character is emitting on the ground and on our enemies as well. So what we can do here, this shadow option selects our entire beauty with this expression. So we'll have to modify this expression here to only work on our holdout geometry. So here we can do holdouts, and we can do a semicolon, then we'll do shadows, and then for this C expression here, let's do CDL like this. So when we do our render now, if we look at our passes and we look at our shadow pass, this is exactly what we want. Now we have only our shadows from our hero character on the ground, and also later when we get close on our enemy geometry with the fracturing, we will also have shadows on our enemies as well. So this holdouts property here is going to look only at our holdout objects. Then from this we are just selecting the shadows, and with this CDL, this basically brings in the total contribution of our lights. So our skies and our dome and stuff like that. So this is how we can set up our hero. Let's maybe look through our camera and just make sure that everything works. All right, so we have all of our combined diffuse and reflections split per LP tag. We have our ambient occlusion. We will need our facing ratio, so we'll have to make sure that this one is set up properly. This facing ratio is basically what we'll use to create our ghosting kind of effect. We have our normal and everything, and especially our shadow. So everything works, and we can also go ahead and render to disk. So these will be our main geometry layers, and with the next lesson we can start setting up our fog layer and also start working on all of the effects. So I will see you there. So let's set up our fog now, and we'll keep things extremely simple. From our out stage, we can just plug a new, let's use a Karma fog box. And for the size here, this will matter quite a lot. So let's first start by increasing the uniform scale by quite a lot. And let's press enter, and with our handles now we can expand the region here. We don't really need to push this too much further out along our camera, because this really won't make much of a difference, but we do need to push this further out so that it reaches the mountains here in the back, and this is how we will get this cool intersection with our mountains, so that we get the separations between the objects. So we'll just make sure that this is big enough, and let's maybe place this even further back and just make this like a super huge object, just enough so that it goes, like I said, into our mountains. If we look through our camera, let's maybe also press Ctrl 2 here and spacebar 1 to preview our camera and perspective at the same time. And I'll just raise this up and maybe even scale this up further, push this back even more. So something like this should be fine. If we look at, let's do a test render with the default settings and see what we get. So right away, let's lower the shadow density and also the regular density to 0.01. And sometimes if you're getting a black screen like this, you will have to reset the viewport. So let's reset using the labs tools here, and let's run another test render. All right, so now we get the proper result. Now, because we have such a large container, maybe it's worth setting the density even lower. Let's use something like 0.005, so we can start to see some of the mountains here in the back. And we'll scale down the colors for this either way. Let's run this through our Karma XPU, and let's actually start to use a Karma render settings node here as well. So let's drop this, and we'll use a new one because we don't really need any of the AOVs from our other render settings nodes. So here we'll use XPU. And also in the case for our fog, we want to render this with a uniform pixel. So in the advanced tab over here, let's set this Oracle to uniform. And we'll also want to point to our camera and set this to full HD. And let's make sure in our rendering camera effects that we disable the motion blur and also the depth of field. So these two settings need to be the same as our other settings here as well. So in our image output, we will just use the beauty here, but we will split this per individual light. So let's split per LP tag, and we will render all of the objects except our Karma fog box as matte objects. So let's stop the render for now and drop down a render geo settings, and let's go to our primitives tab here. So here we can do, let's select all of our objects with slash and star, and then do minus and just select our Karma fog box. So we'll do slash Karma fog box 1, and let's go all the way down here. Let's enable holdout and set this to matte. So now let's also rename this one to JC Fog 01. If we do a render now, hopefully everything will be black except our fog. And we can see that this works. So we can also check our split now as well. So we have our dome, our emission, which is empty, but we have our sky and then our sun. We can also skew our fogs so that it's brighter, closer to our sun. So in our Karma fog box, we can increase this scattering phase here. And I always like to do this just because it looks a little bit more interesting than the flat color. And this also affects our dome and our sky, but more specifically, this affects our sun. So I think with this, we really have everything we need. We could go ahead and render this, so we can just grab one of our render ops and we can connect this here, and you can go ahead and render to disk. So this will be our fog, very simple setup. And another very simple setup that we can do, let's start bringing in the effects layers, and we can start with our tornado effects, mainly because that's going to be one of the layers that requires a more unique setup. It's going to be a very simple setup, but since it's not rendered as an emissive additive object, it will require something a little bit different than what we'll do for the rest of the effects layers. So if we go back to our object level, we can grab our tornado. We'll grab the output from over here, so our out tornado volume. Let's go back into LOPS and let's do a SOP import and bring this here. And we'll want to link this in our chain first of all. So let's drag out another wire. Let's drop down a merge and let's merge this over here. So for our tornado, if we look in Nuke, we have just this intersection with our ground. So really the ground object is the only one that we need. So let's go up and let's drop down a prune node from here before our merge. So here, let's go ahead and let's select our enemies. We'll select our hero, and we can also select let's go to the environment and let's select our mountain as well. So basically we just want to keep our ground, our material, and our lights. And let's do deactivate here. And we can copy the same Karma render settings node that we used earlier, because here again, we'll just render the beauty split per LPE tag. So let's append this here and let's rename this one to JC Tornado 01. Let's also grab our USD render op and connect this here. So this is our base setup. Let's run this and see what we get. We'll also need a render geometry settings for our ground. We'll use this in a second, but we can see that our tornado is working fine. So let's pause this for now and let's grab the same render geometry settings node that we have here, which is with this matte holdout mode, and we'll just run this on our ground. So let's select here for the primitives, we'll do environment and we'll select our ground. So now we need to set up a material for our tornado. Let's drop down a material library. We'll step inside. Let's start with a pyro. Let's use a Karma pyro material, so the default one, and we can rename this one to tornado. We'll go inside and we'll disconnect our AOV nodes from here and also our material properties. So we just need a very simple pyro shader. We'll just increase the density here to 3 and the shadow density to 3 as well, just so this volume is a little bit thicker. So if we go up, let's assign this autofill material and we'll assign this to let's actually rename our SOP import here. We can rename this one to tornado and we'll plug this inside a folder here. Let's do /effects/$OS. So now in our geometry path, let's do effects and we can just assign this to the whole effects group. So if we look at our render now, this is the result that we have. So it's already looking pretty good. We can check our individual contributions. So I believe between all of these layers, we really have everything we need. We can also use denoising for this layer as well, because I find that it works super well with volumes. So in our filters tab here, we'll just turn on optics denoiser and we'll want to run this over all of the AOVs. And really, these are all of the settings that we need for this layer. We have everything we need, so we can go ahead and render this as well. But for this tornado effect, we don't need to render the entire frame range. We can see that this starts roughly at around 1100. So our first frame here, let's set to 1100. 1100. And our last frame, from what I can remember, we know our tornado needs to entirely stop when our split happens at 1365. So that's also where we should have our end frame range. So we'll set this to 1365 and we can go ahead and render to disk. So with the next lesson, we can take a look in all of our emissive and additive layers. So I will see you there. So from here we can start setting up our particle layers. Let's first start with one of the simpler ones. Now most of these will follow pretty much the same setup, but let's start right in the beginning with our aura particles. So if we go back into the object level, in our effects aura PRT, this is where we have our aura effect. So let's also drop down in null after our P scale here, and this will be our out aura PRT. Let's bring this with a SOP import, and also we should note that our frame range here, let's see our file cache, this will also be our render frame range, so from 1030 to 1100. Let's grab this null and let's go back into the lob stage. And maybe we can keep all of the layers that we have previously set. Maybe I'll just drag them over to the side, and from here I'll drop down a new null, and over here below is where we can set up all of our particle layers. So from this new null we can name this one out PRT setup, and let's start by bringing in with a SOP import. We'll bring in our aura particles, and let's just merge this with our scene. And first thing that we'll need to do is create a material for our particles, and let's also set this SOP import here. I will just place this inside a folder called effects like this, and then our materials and everything else we can just link to this /effects path, and this will be our aura PRT. So from here we can do a material library. We'll step inside, we'll do a karma material builder, and essentially we'll just create a simple emissive material. Let's just name this one emissive and step inside. So let's get rid of all of these nodes. We'll want to bring in our color, so let's do a USD prim var attribute. The attribute, or rather the var name here, will be display color with capital C, and let's set this to a float 3 signature, and we can just plug this inside our emission and inside the emission color. And for the emission strength, let's go to the emission tab here. Let's start by setting this up to maybe a value of 10. We'll probably need to bump this up. And for our other settings here, we need the base to be 0 and our specular to be 0 as well. So let's see how this works with just these default settings. We'll go up and we'll autofill materials, assign to geometry, and we'll assign this to slash and our effects group that we created over here. So let's do a new karma render settings node, and this will be our, let's do JC aura PRT01. Let's point this to our camera and use full HD, and also set this to XPU parameters. And all of these particle layers will want to render with uniform sampling. So in the advanced tab, in the pixel oracle here, let's set this to uniform. Now to render this, we don't need any light contribution. So let's go ahead and let's do a prune node from our null, and let's get rid of all of our lights. So here I'll select the entire light group with /lights, and let's deactivate. But now we are going, so if we render this, let's maybe go forward in time. If we render this, there's going to be quite a few adjustments that we have to make, but we first have to get rid of this default headlight. So we'll just do the same trick that we usually do by just appending a new light object here and setting the intensity to 0. So now hopefully we just get our particles with all of the light contributions, so we can see we have some reflections on the ground as well, but we will want to render these particles as a light object. So after the material library here, let's do a geo render settings, and let's run this over our effects object. And if we go all the way down, we should see our treat as light source. Let's set this to yes. So now if we run some test renders, let's also start to separate our AOVs. So in the image output over here, let's add our combined diffuse. We don't need to split this layer, so we'll just grab the combined diffuse, the combined glossy reflection, and in the lights and emission tab, our particle layer will now be in the visible lights. So that's pretty much all of the AOVs that we need. If we do a test render and check out our AOVs, we have our combined diffuse. Now currently this is a little bit too dark, so we can just go in our material, and in our emissive material here, let's just bump this up to maybe 100. So now we can actually start to see our particles, and we can see that it's still not that visible, and this is because our particles are too large and the shadows from the particles are kind of blocking our emissive objects. And we can also see, if we look at our visible light, we can also see that the particles here are way too big either way. So this is what I mentioned earlier, that we can just adjust our particle scale directly in Solaris. So after the render geometry settings, or actually let's do this before, let's run our p-scale setup, and I already have this prepared as a recipe. So I have here vox adjust p-scale, and let's make sure that this runs on our effects/points object. So we are multiplying the width primvar here by a certain amount, and we also have this option run on elements of array attributes, and this is running on the actual points object from our effects layer. So now if we render this one more time, our particles, we can see that we can now affect their p-scale. And also if I just preview our visible lights, and let's also go to our correction toolbar, and maybe we can lower this, we can see exactly what we are going to render, and probably we can decrease the p-scale even further. Let's just decrease this even more until we get this thin wispy layer. So something like this, maybe something like 0.02 in this case, will give us a good result. And also on most of these layers, I will also want to run an optics denoiser, because I found that this works really well. So in the filters tab, let's turn on NVIDIA optics denoiser, and let's run this over all of our AOVs. Speaking of which, we can also go back to our combined diffuse, and let's reset our brightness. So now we can actually see some of our reflections here on the diffuse and our reflective surfaces. So this is exactly what we want. With our visible lights, we have everything we need, but we still need to address the motion blur. So let's go back in the object level here in our aura particles, and let's just make sure that we have velocities on our particles. And we can see, unfortunately, if I turn on the point trail display, we don't have velocities, and this is because we didn't compute the velocities, and we should probably do this in the case for our aura particles. After this point deform over here, let's maybe press escape and go back to the first frame. After this point deform here, we should really run a trail SOP, and let's compute velocity, match by attribute, which will be ID, and in our attribute delete, let's also keep our velocity as well. So I'm going to go ahead and recache this simulation. Actually, before we save this, let's go ahead and place this trail SOP before our point deform. So let's plug this over here after the time shift. Because this point deform at certain parts of the animation will move our particles in sort of weird ways, and we don't really want to stretch our points along this computed velocity from over here. So it's best if we just compute the velocity on the regular PubNet simulation before any point deformation. So let's go ahead, and now we can run our file cache. So if we look at our simulation now, we should have the correct velocities, and let's go ahead, let's go back at the stage level. And now with velocity on our points, if we go to our rendering, we can go to the camera effects. Now we don't need any depth of field, but we do want to include motion blur, and we will need to turn on this velocity blur. Let's set this here to velocity blur. So if we look at our particles now, we should have motion blur on the particles with based on our velocities. So let's give this a second, and for now I will just disable the denoiser just so we can check that our particle velocities are working. And we can kind of see, maybe I can zoom in here. Let's try to zoom in on the particles here, and hopefully we should see some of our velocity blur. And we can kind of see this here, especially as I zoom in closer. Now this layer, this particular layer isn't moving that fast, but we do see this clear smearing. So this is exactly what we want. And we can go back to through our camera. Now when we turn on in the rendering tab, when we turn on motion blur to use our velocity blur, we also introduce back the motion blur from our camera. So if I were to disable this, we can see roughly a few frames before where our camera, for example, zooms in on our character really fast. So probably at around this part right here. When we preview this rendering, this will now give us the motion blur from our camera as well. It's not that noticeable here, but all of these particles have sort of like a little bit of this radial ray. That's again, we can see this clearly over here that we have kind of like these rays that push towards our character basically from our camera zoom in. So we want to avoid the motion blur from the camera, but we want to include the motion blur from our particles. So to do this, we can disable motion samples from stage, and for our transform time samples, we can set this to 1. Essentially, our camera animation is part of these transform time samples. So when we set this to 1, we are just looking at 1 frame for our camera. So we essentially turn off the motion blur, but just for our camera. And now hopefully if I zoom in on this, we can see we no longer get these radial rays, but we do have the velocity blur on our particles. So this is exactly what we want. And now with this layer, we have everything we need. We can go ahead and drop down a USD render up, and we can save this. We mentioned earlier that we'll want to render this from 1030 to around, let's remove the expression here. I believe it was 1100. We can check the file cache to make sure, and we can also set this to Karma XPU, and we can go ahead and render this layer. So now that we have our first particle layer, let's see if we can translate the same setup for our next layer. So I'll grab all of these nodes and let's just duplicate them over to the right and maybe make some more room. So let's bring in our next layer, which can be really, there's no order here, but we can bring in our explosion next maybe. So let's go to our object level, and inside our explosion PRT, here we have our out explosion node. Let's check. All right, so we can see first of all that we have velocities on this, which is perfect, and this layer starts at around 1100, and we can render this probably up until 1170 or maybe 1175. If we check our cache frame range, we have 1175, so let's use this frame range as well. All right, so we'll bring this, let's copy the path and let's paste this inside our SOP import here, and we can change the name. The name here doesn't affect our chain. We are not linking this name of this node in anywhere inside this node. So let's just name this one explosion PRT. This is mainly just for our graph inside this window here. And we can also rename this one to JC explosion PRT01. And let's move to around 1119 or so. And let's see if we have this layer. For some reason this isn't showing up, so we just have to frame in on this. All right, and let's move back here. So we have our particles, and let's do a test render with the same settings that we have. So all of our P scale and rendering as a light and everything else. So if we do a test render, let's see what we get. And let's use here our normal high quality lighting. So if we let this load for a second, this is what we get. So this is looking pretty good. Probably the P scale here is too low, so let's maybe increase this back. Let's set this to maybe a value of 0.1. All right, so probably something like this is more along the lines of what I'm looking for. We can already see that our velocity blur is working, which is perfect. And we can inspect our AOVs as well. We have our combined diffuse, glossy reflection, and our visible light. So also while we're previewing this, with our correction toolbar, if we lower the intensity here, we can get a better idea on what we are actually going to comp in. So this is looking pretty good, but we can see we have a lot of these particles that are right in front of our camera, which I kind of want to avoid this messy part here. So we can just scale down the particles that are really close to the camera. We can, let's stop the render and let's go back to the object level, and inside our container here, we can just make some more room and we can do another attribute VOP, which will be, let's do scale by cam, or actually we can do this in our set P-scale attribute VOP. I believe this makes the most amount of sense. So let's bring in our camera position with an object merge, and here we can go to our, inside the OBJ level, we can look to our camera, and let's make sure that we are bringing in the camera object from over here. Hit accept. So here we have the camera, and let's turn on, let's set the transform here to into this object, and now we also see the animation. We'll turn this into a single point. So let's pack geometry before merging, and now with the single point we can reference this in our attribute VOP. Let's step inside. We'll place our camera as the second input. So if we step inside from op input 2, we can do an import point attribute. We can promote the ptnum to a constant of 0, and we want to bring in the position. So we can just run a distance from our own position. Let's drop down a distance. We'll measure it to the position of our camera, and we can export this as our color just to preview our values. And let's look at a frame here, maybe at around 1100 or so, and let's do a feet range after our distance value. So now we can push our values. If I set this to maybe a value of 5, we can see this fading over here. If I show all objects, if I also go up, so we can template our camera, we can see that this is the distance that we are measuring. So if we step back inside, as I run the simulation, we can see that when we get roughly to around this frame, this is the part of our particles where I would want to scale them down. So we can increase the source mean as well, maybe to a value of 2. So we get something like this. And now really all of these particles that are right in front of the camera, let's maybe set the source mean to 1. All of these particles will be scaled down, and we can just multiply what we already have over here. Let's set a multiply after this multiply constant, and we'll multiply this with our feet range values. And we can get rid of the color connection for now. So if we go up, if we go back into our viewport, we can do another test render. So now we can still see some of these particles that are close to our camera, but we are avoiding all of the particles which are rather large if they're right in front of the camera, and can often lead to messy results. So I often do this with a lot of these particle layers that come super close to the camera. Obviously, you can play around with the feet range settings for the distance if you want to smooth out this scaling more or less. So this will be up to you as well. But something like this, I believe, is giving us a fairly cool result. This is very close to the final render that I ended up with in the original project. So I'm pretty happy with this. We can go ahead, and for most of these layers, we can see that we have pretty low samples. Probably for this, we should bump up our trace samples to 256 or maybe even more. And this will also be up to you, depending on how much time you want to invest rendering. So if you want, you can bump up the samples here, and also for these other layers as well. As long as you make sure that in the advanced tab, you are rendering this as uniform pixels. So now we have everything we need for this layer as well. We can go to our image output, and also here we will want to use the optics denoiser. And this is also a personal preference. We can see that in this case, I believe it creates a pretty good result. Since this is an additive layer, we can get away with this denoiser, but it doesn't always work, so be mindful where you use it. But with that being said, we are ready to render this layer as well, and we mentioned we want this from 1100 to around 1175. So we can go ahead and render to disk, and we can move on to our next layer. So let's grab another duplicate of all of these nodes. We'll drag them over to the side, and for our next layer, we can start working on our slice particles. So let's go into the object mode, and here we have our slice PRT, and from over here, from our out slice, let's maybe preview this. All right, so this is the layer, and let's copy this node and let's paste the path inside our SOP import. We'll paste this over here, and this will be our slice PRT. And again, we'll want all of the same settings for this as well. Let's rename this render settings here to slice PRT01. And if we do a test render with all of these default settings, let's see what we get. Let's see if we need some adjusting on the P-scale or anything else. And again, we'll disable the denoiser just for now. So let's set this to no denoiser. So with this layer, let's go back to the object level, and inside our container we can see that we just have at around this part, which is kind of like the middle part, we have only around 2 million. So for our final result, we probably need to bump this up to around something closer to 10 million to get the best results. So here I will run another simulation in case you haven't already. I'll go to the scatter here, and let's say that I want to end up with around 10 million. So I will have to bump this up by a factor of 4 or maybe 5. Let's maybe just set this to 1200. All right, and we will run another simulation here. So let's save to disk, and we'll give this a second. So after the file cache, I ended up with roughly 9 million, and this should provide a much nicer result. So if I go back to Solaris, let's render this result now, and after we let this load for a while, this is what we get. So we'll turn on the optics denoiser here in a second, and this will help to smooth things out, but we don't have any velocity blur on these particles. So if we go back to our object level and inside our container here, if we turn on the point rail display, we do have velocities that we inherited from our simulation, and let's maybe preview this from our file cache. We have a little bit of this velocity initially when we are spawning the particles, but after we apply the drag and the slowdown, this velocity essentially disappears. So what we want to do is render these in a state where they do have velocity blur, so we do want to continuously smear them throughout this entire simulation. So we just want to create a velocity attribute that's pointing in the same direction as each slice is pointing. And over here, if we remember our setup with by looking at the curves, here where we are referencing the curves to create the p-scale, we can also do another attribute VOP, and we can name this one to set V. We can reference the same curve geometry inside, and this curve geometry, we have to remember that we have this normal attribute that's pointing along the direction of the curve. So we can just look at this normal attribute and use it as our velocity. So let's go ahead, and we want to use the same setup as our set p-scale from over here with the XYZ dist. So if we grab these two nodes, the XYZ dist and the premium V, let's copy these two nodes, let's plug them in our new attribute VOP, and let's also color this orange. So we'll step inside and let's paste these here. And here let's set the input for, let's make sure that our XYZ dist and our premium V are both pointing to op input 2. And for our premium V here, we want to use a vector attribute, and we want to look at our normal. So if we plug this inside the velocity, let's preview our attribute VOP. We should see now, if we look at our point rail display, that we do have this velocity that's pointing in the same direction as our curve, as we can see over here. So we can scale this up. So let's do a multiply here and promote the second input. So maybe we can rename this one to V multiply or something like this. So if we go up and scale this, we can determine how much we want to smear our particles essentially. So we'll want to go over the default value of 1 here. Let's use something like 2 or maybe even 3. And let's also add this value on top of the velocity that we already have from our particle simulation. So we'll step back inside and we'll grab our velocity as it is. Let's plug this in inside the V output here, and let's do an add, and let's plug the multiply result in our add. So now we can go up, and let's preview this and see how this will look rendered. So in our Solaris stage, let's do another test render, and hopefully we should see this smeared look on our particles, and this will help smooth everything up by quite a lot. So we can already see this result over here. Let's maybe zoom in. We have this we have now this nice smooth result, and when we turn on our optics denoiser on top, we will have an even smoother result. So let's give this a second, and let's just see what we get, and maybe we can also preview this directly from our visible lights layer. Alright, so we end up with something like this. Probably for this layer we would have to increase the path trace sample, so I'll leave this up to you. But if I were to lower this light a little bit, this is the result that we get. And also something that we should have probably set earlier in our rendering tab inside the limits, we should bump up the color limit here maybe to 100, just because we are using a high emission value. So we would have to bump this up as well. And we probably should use this setting for all of the other render settings node as well. So this one is also 100, and our aura particles is also, we should set this to 100. But moving back to our slice particles, one more thing that I would like to change. Now we see that when we do our rendering, we no longer have that clamped white value, and we actually have this nice gradient in our blue color. So this is exactly what we want. And if we check out our other passes as well, we can maybe experiment here with our p-scale for the particles. So maybe I can just increase this to maybe 0.15. I'll make them just slightly bigger, and let's turn off the denoiser as we are doing some further tests. All right, and something like this, I believe, looks pretty close to what I ended up with. And here as well, in the original render that I did, I had to scale down the particles along with the camera as well. So for example, these particles here that are super close to the camera, I would probably need to scale down their p-scale by using the same distance to the camera setup. So we already know how to do this, and I'll leave this up to you. Again, you just have to bring in the camera with an object merge, reference the camera's position inside the p-scale attribute VOP, and just measure a distance and filter it through a fit range node to decide how you want to scale down the particles. And as I'm seeing some of these frames, I can say that I'm pretty happy with this layer. So we can also go ahead and render this to disks. So I believe this layer we should render from 1200 to 1400. Let's maybe just check the file cache and see what frame range we rendered here. All right, so it's 1200 to 1400. We got everything we need, and we are good to go with this layer as well. Just make sure you don't forget to turn back on the optics denoiser here for the final render. And from here we can set up our next particle layer, which will be the after slice particles. And of course we can use the same setup. So let's duplicate all of our nodes one more time, and let's go back to the object level. We'll go inside we placed our particles inside the RBD setup over here. So we have our after slice particles, which is this layer. So here we also don't have our blue color, so we'll take care of this in a second. We just have the regular black and white gradient as a color. So let's grab this and let's link this back to our SOP import over here. And this will be we can name this one after slice PRT. And let's just see if our setup works as it is, and also rename this one to after slice PRT. And let's just run a render, see what we get. And for this specific layer, because the particles aren't moving that much, I think we can get away with not using any denoising. And also in our render settings, we don't need motion blur on this at all, because our particles are static. They're not moving only really when the enemies are falling. So we don't really need any motion blur. And if we zoom in on this, let's see what we get. Now, first of all, let's introduce our color. So we can go back to the object level, and inside our RBD setup here, let's use a color node after the file cache, and we can just set this to our blue gradient. So we'll use the attribute here CD, and we'll change our white color here. We'll use a light blue with some desaturation. So this will be fine. So if we now go back, let's take a look, and we should now see our proper colors. But one thing that we have to fix here, we can see that there's quite a bit of intersection with our geometry. So we will have to push out our particles using the normals of our geometry, and we probably should have done this from the start. So let's go back to our object level, and inside our setup, right where we generate our scatter from over here, we can use a peak node after this blast. So if we drop down a peak node here, we can just push out our geometry further out with a very, very low value. Let's use something like 0.002, and then we can run our scatter on this geometry. and then we'll run our color and our solver setup. So then if we run our transform pieces and the rest of these operations, we can compare and we can see that our current result compared to our old result looks something like this. So our points are just slightly pushed further out from the geometry. So let's go ahead and recache this new simulation. So we have our new cache now with our color, and if we go back, let's hopefully see, and we now got rid of our intersecting problem. So if we look through our camera, we should have our final look here, and let's give this a second, but I can say that this is looking pretty good. So we can inspect the AOVs as well, but I think we have everything we need in terms of this layer. So from here we can also go ahead and we can render this as well. Let's check out the frame range. So we have the same as our slice particles from 1200 to 1400, which we already have set, so we are good to go with this layer as well. And finally, our last additive layer that we can add with the same setup is going to be our electricity. So let's duplicate all of these nodes one more time, and let's bring in our electricity. We'll go back to our object level and we'll go inside our electric container here, grab our out electric, and this one is from 1365 towards the end of the timeline. So let's grab this, let's paste this over here in our SOP import, and we don't need this adjust p scale here because we are rendering this as just a simple geometry with primitives. And let's also rename this one over here JC electric PRT01. And let's step inside the render and see if the defaults, if our current setup is working here. So everything seems to be working fine. We can inspect our AOVs as well, and we have a pretty good result. We probably can bump up the emission values for this layer specifically. So we can go in our material settings, and here we can bump this up to, let's say, maybe something like 500, and hopefully now we have a little bit more reflections on our ground as well. Now we have a problem here. I'm not sure why this happens, but we can see that some of this reflectivity over here is spilling over on the mountains in the back, which doesn't really make sense because the mountains are super far away and we really shouldn't have this happening. And again, I'm not sure why this happens, but when I set this to render with Karma CPU, we don't have this error happening here with our mountains in the back, and we have our expected result. So this might be a bug, or I haven't set up the material properly for the mountains, but for this layer we can just use Karma CPU and it should be a fast render either way. So we can go up, and that's pretty much all we have to do for this layer, and this will be our last additive layer. And now we have almost all of the render layers that we need. Finally, our last layer, which is more of a utility layer, we can set up our sliced planes render, which is going to be this render over here. If I head over to Nuke, we have our planes, which is just our plane geometry with some random colors set to transparency. So we'll go over back to Houdini, and we'll just create a separate chain for our planes because really we just need our camera for this to work. So if we go to the object level inside our slice PRT, this is where we set up our planes, which is this geometry over here. And because this is based on our particle simulation, we should have an attribute on our planes, which is going to be this ID orig. So if I turn this on, we have a unique value per individual plane, which we can use in our shading. So let's grab this and let's go back to Solaris. And over here to the right, or maybe down below, we can do a SOP import, and let's just bring in our planes. And here from our main setup, we just need our camera. So let's grab this cam sublayer. We'll bring this over here, and let's do a merge, and let's bring in our planes. So we can see we have access to our camera, and these will be our planes. So from here we can do a Karma render settings, and we just want to, let's set this to XPU, and we just want to disable our depth of field motion blur, and here we'll set this to 1080p, and let's use our camera path, and we'll just render this. We just need our beauty, so we don't have to set up anything else. Let's do a quick render and see what we get. So let's create a material now we'll do a material library, we'll step inside. Let's drop down a Karma material builder, and this will be our planes. So we'll step inside and we'll want to create a random value per our ID orig attribute. So let's use a USD primvar reader and let's bring in our ID underscore orig. This is an integer, so let's set the signature here properly. So from here we can create a random value. So if we do a mtlx random float, we can use this as the seed and we can plug this in our material. We want to use this in our emission, so we want to use some emission here and some transparency. So we'll go to the transmission as well and use the same value for our transmission. And for our other settings, let's set the base to 0 and our specular to 0. And I believe this is pretty much everything that we need. So if we go up, let's assign this, let's autofill materials and assign this to our geometry. And I'll just assign this to this SOP import node that was created. So now if I do a test render, we can see that all of these planes will have a random emissive value and random transparency as well. And for some reason we also have, let's go back inside here, and because we are inheriting the roughness of our specular values here, this roughness that we have is also what our transmission roughness is using, so we have to set this one to 0 in order to not render this with any roughness. And actually in this case, instead of using the transmission, let's remove this connection so it's 0 and let's use the opacity instead, because the transmission will give us maybe too much geometric information. So let's go to the geometry here and let's plug our random value inside the opacity. So now I think it's a little bit more controlled, and we still have all of these nice sharp lines over here, which will create a cool displacement in our compositing. So this is really the last layer. You can go ahead and render this as well. And we have now all of the layers that we need to start compositing. So with the next lesson, we can start up a new module and we can dive inside Nuke and start compositing. So I will see you there. We are ready to start compositing. So I brought in all of our renders. Here I have the main 3 geo render layers. And here we have all of the effects layers. And then we have our camera and our sky. So you can also go ahead and bring in all of the renders, or you can bring them as we use them to build our main chain. Now for the project settings, if we hover over this window and press S, we have the frame range from 1001 to 1450, FPS 24 and full size format of HD 1080p. And in the color here, we have set the color management to OCIO and ACES 1.2. So these are the settings that you need. And we can go ahead and just like the other projects, first we'll do our slab comp. We'll split up the AOVs for all of our renders and layer them all together without doing any grading adjustments or anything. And then with the next lessons, we'll come back, start from the top and do any changes that we need. So first, our furthest away layer in this composition will be our sky. Let's start by just bringing in our sky texture over here. So it's the same HDRI that we kept using from Polyhaven. And we have also our camera. So just press tab and bring down a camera node, set this to read from file, and just point this to the same USD camera that we used in our Houdini project, which will be this jccam01.usd. So once we have this, we need to apply this texture to a sphere. And because we have this main section over here where we spin our camera 180 degrees, we will need this sky to exist on sort of like both sides of our scene. So we need to wrap our texture around an entire sphere geometry. So let's just drop down a sphere and point the image to our texture, and we'll keep the settings as they are. We'll just increase the uniform scale here by quite a lot. Let's start with something like 100, and if we preview our camera as well, we can see where our camera roughly is. So probably something like 100 should be good for our size. We can maybe push this even more. We can do something like 500 just to make sure, and something like this will be fine. So from here we can just do a scanline render. We'll point the cam to our camera and our object to our sphere, and if we look through our scan line now. If we press tab, we can see that this is now following our camera. So already we have the sky. Now we mentioned that we are not going to do any grading, but for this sky specifically, I will just drop down a simple grade node and just gain this down, simply because the sky might be a little bit too bright. And we'll do a lot of adjustments later, but this super bright sky will kind of bother me as I add the other layers as well. And let's make sure that this over here says RGBA, so we can also preview our alpha. So we have our sky, perfect, and then the next layer really should be our environment. So we can drag this render over here, and we can start to shuffle out all of our AOVs and rebuild the beauty. So let's do a shuffle, and the same thing that we always do. Let's go to the node here. Let's set the expression value in 1 for the label, and then we can start shuffling. So let's bring in our combined diffuse sky. We'll do a merge with M. Let's do another dot here, and let's start to duplicate these shuffles. We'll connect this here. Let's bring down our merge, connect this here, do another dot, and I'll reverse the order, so it's B on the left, and the operation here will be plus. And for our second one, let's bring in our next combined diffuse, which is our sun, and we'll do now one more copy for all of this with Alt C. Let's link this up. For our third one here, we can do our, let's bring in our dome. So now we have all of our combined diffuse contributions. We can grab all of these, we'll do another duplicate, link them up in our chain, and for our fourth one, we can bring in our combined glossy reflection sky. For our fifth one, after the sky, we have our sun, and we'll do one more for our dome. Let's link this up over here, and we'll bring in our dome. And I believe for our environment, these are all of the passes that we need. So if we compare this with our final result, we have exactly the same. And because we have alpha over here, we need to unpremult all of these layers. So let's do them per individual shuffle. We'll go back to our first one. We'll also bring in the alpha from our main render, and we'll plug this in our output alpha, and then we can do an unpremult. So we can see now that our edges are working, so the unpremult is working, and we'll have to do the same for the other ones. So I'll just go one by one for each of these shuffles, and I'll add the alpha and then just copy the unpremult. So let's plug this over here, and again we see that this is working, and I'll just do the same for the other shuffles as well and pause the video while I do so. So we have the unpremult for all of our AOVs, and if we compare our renders, we have the unpremulted edges that we need. So from here we can do a copy node with K. We'll plug the B layer back to our render, and we'll reverse the order here. So our A layer is our main render, and we can copy the alpha back, and then we can do a premult after our copy node. So we bring back our edges. So again, the same setup that we always do. We probably could have copied this from the other project files, but I just prefer to build this from scratch usually, because the name of the AOVs might change sometimes. So especially the LPE tag that I set, sometimes we don't have sky, sun, and dome. We might have named our lights other names. So usually I just prefer to set this up from scratch, but we can use the same setup, and we will use this in a second for our other geo layers as well. So we'll let's grab all of this. We'll hold down Control on our last node here, and from here we'll do another merge, and we'll just bring this over our sky and leave the operation as over. So if we preview this result, let's add another dot here, and let's just double check that our camera is working with the sky. So if I just preview maybe a few frames here in the middle, we can just cache a few frames, but we can already see that our sky is working. So it's following our camera, and we are good to go with the next part. Let's bring all of our geo render layers first, and then worry about the effects. So our next layer will be our enemies. We'll bring this over here, and we can just copy the same setup. Let's copy all of these nodes. We'll Control C, and let's paste them down below. Let's link this up to our render, and we should have the same shuffle. So if we just look at our render as it is over here and compare it with our premult result, we should see the same render. So as I switch between these two, we have the exact same thing. So we can just safely merge this on top. We'll grab this last merge, hold down Shift and select the other merge, and press Shift Y to create this connection. So we have our characters also split and on top of our ground. We can see that we'll have a lot of color correcting to do. And we can also bring in our main hero layer with the same setup. So we'll grab these one more time, press Alt-C to duplicate. Let's link this up over here with Shift-Y, drag these over, and instead of this render, we'll just grab our hero render. So let's bring this down over here and let's switch these renders. Let's point to our hero and let's see if this works as well. It should work. And we'll preview a different frame, an earlier frame here in the beginning, and we can see that our hero layer works. And specifically for this hero layer, let's not forget that we have to bring in the shadows separately. So to do this, let's maybe make some room. And actually, we have to place our shadows below the main merge of our character. So over here, we can just copy one of our shuffle nodes. Let's copy this, link this back to our render, and we need to bring in here. We don't really need the alpha, so we can disconnect this channel, and we'll have to bring in our shadow pass. So we'll want to do a grade node from here just to reverse or rather invert our values. So we'll set the white point to 0 and the black point here we'll set to 1. So we can see our shadows over here and we can do a merge and set the operation to multiply. So now we have this over here. We'll have to do some further grading to get the shadows that we want, but if we drop down just another grade node for now and reduce the gamma, we can kind of see our shadows now. We'll have to grade this according to our environment as well, but we have our shadow, and when we plus or rather merge our character on top, so we can clearly see our shadows working. Now normally the shadows are connected to our main lights, so our sun, our dome, and our sky. And normally to get the most amount of control and to match this with our grading for the characters and the environment, we would have to split the shadows per individual light as well. But we are not trying to be super accurate. Really, the combined shadows of all of our lights in one single AOV, but that's just a little side note on how we should technically approach this. So now that we have our main geo render layers, we can start to bring in some of our effects. And the first effect that we want to bring in is our tornado, because that will require a separate setup than the rest of the effects. So let's look for our tornado, which is going to be this layer over here. And we will want to add this in between our environment and the character. So if I bring this down below, we'll just place this after our environment over here. So we can hold down Control and I'll just drag all of these nodes up like this. And maybe I'll just move our renders out of the way. We'll just place them over here. So with our tornado layer, we will want to run the same setup, but here we just have our beauty split per individual light. So we have 3 layers that we need to split, our sky, sun, and dome. So we can just grab from our environment render 3 of these shuffles. Let's copy these and paste them over here, link this to our render. So our first shuffle here, we'll change this to sky. We'll want to run our unprimal setup as well. We can see that when we run this, we have quite a different result, and this is because we have this very kind of faded alpha, so this is why it looks dramatically different, and this is a specific thing for volumes. So anyway, we can bring next our sun, and then we can also bring in our dome contribution. We'll add all of these together, and from here we'll copy back our alpha from our main render. Let's reverse the order, and we can now do a pre-mult from here, and we can just merge this over and hopefully it should work. So we have our tornado now as well. Let's make some room, try to space these out a little bit. So we'll need some further controlling here in a similar way in which we added our volumes in the daemon project. We'll want to control the thickness of this layer through the alpha channel. So we'll handle that when we come back to this part. But for now, we can move forward with the rest of our setup and we can bring in our fog. So let's bring our fog layer from over here. We'll drag this down, and really this normally would be added on top of everything. But in this specific case, I rendered this fog without our main hero character. And this is because we have to fade out the character when he charges towards the camera. So we need this fog layer to not include the matte of our character, specifically so we can do this fade out. Now in this case it doesn't really make that much of a difference because our fog will mainly exist behind our characters. So in fact here we could have probably rendered this fog without the enemies as well, and we would probably still have the same kind of result. But with that being said, I will just place this fog before our hero layer over here. So we'll just place this after our enemy layers. We'll bring the hero down below and we'll place our fog over here. So here we have our enemies, and then after this will come our fog, and we need a couple of nodes over here. We'll want to bring in the same beauty shuffles that we have in our tornado. We just need 2 of these, so let's grab 2 sets of shuffles and let's paste them down below. We'll link this to our render. So here we have our sky and our sun, and we don't need the unpremult in this case. We just want to merge these together, and then this will just do a merge on top of our main chain. So let's bring this over here like so, and for now we'll also set this merge to plus, and we can see that everything lines up. Let's just maybe do a gray node after our plus and just gain this down by quite a bit. So this is what we have, and when we add our character on top, we can see that this works nicely. And this is again because our fog, especially after we do our grading, we can see that it doesn't really interact that much with our characters, maybe only in the beginning at around these parts, but we'll handle this part in the next lessons. So we also have our fog, and this will be the main result so far. And from here we can start bringing in all of our additive layers, so our main effects. We can start with our aura particles, which happen the earliest in our animation. And also here we can see the first frame of our tornado. Let's just go to our tornado read node, and here we can set the frame range. We'll set this to black and also black at the end as well, just so we don't see this first frame throughout the entire animation. So let's bring in our aura particles. We'll drag this layer all the way down over here, and all of these additive layers will follow the same setup. So let's bring in a shuffle. We'll just copy one for now, and let's bring in our, so with our first shuffle, let's bring in our combine diffuse. We don't have any LPE tag separation, and we don't need to unpremult this. We'll just do a merge, and we'll do a copy. And for our second shuffle, we want to bring in our combine glossy reflection. We'll just add these together. Let's set this to plus, and we can also just merge this in our main chain. Let's do Shift Y, and this operation here will be plus as well. And we'll also want to bring in our actual particle, so maybe I'll just drag this over to the side, add another dot, and let's copy one of our shuffle nodes, link this back together here, and maybe do a connection. We'll do something like this for wiring, and here we'll bring in our visible lights. And this will obviously add our glows and do a lot of post-processing, but for now we'll just merge this on our chain, set this to plus, and here we have our aura particles. So this is the base setup that we'll use for all of our layers. In fact, from here, we can just make some more room, and we'll grab all of these. Let's Alt-C to duplicate, bring them down below, and link this to our main render, and we can just replace this render now with our next layer. So let's maybe bring in our explosion next. We'll bring this all the way down here, or we can just Control X and let's paste this down below, and we can just replace our main render here. So hopefully now if we move forward, let's move forward to around 11:30 or so, we should have, if we just preview the result of our combined diffuse with glossy reflection, we can see that this works, and with our visible lights on top, we also have our particles. So we'll copy this setup a couple more times, I believe. Let's do another duplicate, link this over, and next we can bring in our build up particles. So again, I'll Control X to cut this node, and we can paste this over here, link this up, and let's see how this layer looks as well. We have our reflections, and then we have our main particles, and we'll add this on top. Perfect. Let's do this one more time, or probably at least a couple more times. Link this up over here. And for our next layer, let's see what we have left. We can bring in our slice particles. So let's cut this layer as well. bring this down below and replace our render. Double check to make sure that this is working. We'll go forward after 1200. All right, we have everything and we have our visible lights. Perfect. So we'll do this one more time. And the reason we are separating all of these really is because we'll need different grading adjustments and glow values. And it might seem a little bit overkill, especially when we just add them as we are now with the same settings, but it will make a lot more sense when we actually start to grade things. And for example, some layers we might want to add some flares and some layers we might want to not have them. Some layers we can use to add some displacements, and I just prefer to have this control over the final look. So we'll connect this again and we can bring in our, let's do our after slice particles, and we have one more for our electric. So let's for now cut our after slice and bring this down here, replace our last render, and let's make sure that this is working as well. All right, and our main particles. So one more additive layer, we'll do the same thing. Let's copy or rather duplicate all of our nodes, and with this layer we'll bring in our electric particles. So here let's go ahead and grab our electric. We'll place this down below, and this will be our last additive layer. So this one as well, when we check, our reflections work and our visible lights work as well. So we'll add this over here. We have one more layer, which is our planes, but really we'll just add this at the end when we do our displacement. So we'll just leave this layer over here, maybe bring this next to our sky somewhere, and we'll save this as the last layer. But now we have added everything, and we can see that especially after we introduce more nodes in between our main chain, this might be stretching a little bit too much vertically for my taste. So sometimes I like to just do a zigzag kind of thing. I like to split the chain up into two separate columns. So what we can do, and we can do our split after our last geometry layer here, which is our character. So if we look for our character, and this is where we add this, we can do a no OP node after this. So this is like a null. It's just an empty node, and we can disconnect our main chain from here, and we'll bring all of our additive layers. We'll grab this entire chain and we'll just drag this over to the right, and we'll add another no OP node here at the top. We can link this back to our main render, and now we'll just link our no OP nodes. We'll grab this over here, the one at the end of our character, and we'll grab this one. So while holding down shift, I'll select the second no OP node as well, and we'll do shift Y to create this connection. So if we follow our chain right now, it goes all the way down, then it's gonna come back up to the right, and we'll continue our chain down below. So we have this kind of zigzag thing. Now this is just a personal preference on how I like to set things up when the comps are maybe a little bit too big to just run down a vertical line. I find this a little bit easier to stay organized, especially since all of our layers here on the right, we know that these are the additive layers. So these will, even after we add all of our adjustments, these will mostly follow the same setup for our glows and for everything else. And we don't want to see this diagonal wiring here, so I'll just go over here to my second NoOP node and press Alt-H to hide the input, and if I deselect this now, we don't have to see this. And with this being said, this will be our main slab comp. We can see that right away our final result will look vastly different from what we have currently. So let's start with the next lesson. We'll go all the way back and start with our sky, make the sky look cool, and then start to do some grading for our geo layers, and we'll probably work on multiple layers at the same time. So I will see you in the next lesson.